Imagine for a moment, just imagine this for a moment. You're in your chemistry lab, holding a test tube in your hand, and you have a lab book in front of you, in which the procedure of the experiment is written. You read that procedure, and according to that, you start adding chemicals into the test tube. And suddenly you see fumes coming out of it. Or you see that the test tube is getting, or you feel that the test tube is getting warmer and warmer. Or you see that the color of the liquid inside the test tube has been changed. Isn't this fascinating, ladies and gentlemen, boys and girls? But have you ever wondered what are the basic laws in chemistry which governs the chemical reaction happening in the test tube? For example, if I take an object and I take it to a certain height and drop it, so is there any law which governs the falling of that object? Yes, there is, right? Use Newton's kinematical equation. We'll be able to find that at what time, at what place it is from the moment and the point from where you have dropped the object. Isn't it, ladies and gentlemen? So are there any laws which governs the chemical reaction happening in that test tube? Certainly there is. And I should say certainly there are. Today in this video, we are going to study 5 basic laws in chemistry which governs that chemical reaction happening in that test tube, or for that matter anywhere in the universe. So let's get started. So the very first is, and this is one of my favorite, is nothing but the law of conservation of mass. It was stated by Antonio Lavoisier in 1783. This law states that during any chemical reaction, the mass is neither created nor it is destroyed. It means that the mass of the reactants before the reaction and the mass of the products or products after the reaction is always equal. For example, the reaction of carbon and oxygen to form carbon dioxide. If there is X gram of carbon and Y gram of oxygen, so the amount of carbon dioxide will always be equal to X plus Y grams. Second is law of definite composition. This was stated by again a French chemist, Joseph Proust. He said that any pure compound always contains the same elements by definite proportion of weight, irrespective of its source or method of preparation. For example, you have a chemistry lab and you generate a water in that lab, and then you go out and you collect a sample of water from a river, provided that the sample of the water should be pure, which is not the case ideally, but let's assume it is pure. And if you compare both the sample, you'll find out that they are chemically identical. Both the sample will contain 2 atoms of hydrogen and 1 atom of oxygen. That's what this law means. Next is law of multiple proportion. It was stated by a British scientist, John Dalton, in 1803. He said, if 2 elements combine together to form 2 or more products with different composition by weight, then the masses of the interacting elements in those compounds will bear a simple whole number ratio. For example, carbon and oxygen combine together to form carbon dioxide, or they can also combine together to form carbon monoxide. Now in case of carbon dioxide, for per gram of carbon there is 2.66 gram of oxygen, and in case of carbon monoxide, for per gram of carbon there is 1.33 gram of oxygen. If you take the ratio of 2.66 and 1.33, it will come out to be 2:1, which is nothing but a whole number and which certainly obeys law of multiple proportion. Next is Gay-Lussac law of combining volume. In 1808, Gay-Lussac studied various chemical reactions of gases, and he generalized a law. It states that if gaseous reactants combine together to form gaseous products, then the volume of the gaseous reactant and the volume of the gaseous product have a simple whole number ratio. Again, let's try to understand this through an example. Let's take an example of hydrogen and chlorine to form hydrogen chloride, and the coefficient in front of them determining the volume. Now, as you all know, that hydrogen and chlorine, they both are diatomic gases, they exist in pair. Now if we try to balance out the equation, you'll find out that one volume of hydrogen combines with one volume of chlorine to form two volumes of hydrogen chloride gas. Now, if you take the ratio, it will come out to be 1:1:2, which is nothing but a whole number and which certainly in agreement with Gay-Lussac law of combining volume. Next one and the last one is Avogadro's law. This is nothing but a little bit of modification of Gay-Lussac law. It states that equal volume of all gases under identical condition of temperature and pressure contains equal number of molecules. For example, if you have a two container, in one container there is oxygen gas O2 and in another container there is nitrogen gas N2. Now if you keep both the container under identical condition of temperature and pressure, let's say we keep them at STP and the number of molecules in both the container is also same. Let's say 10 molecules in both the container of oxygen and nitrogen. And if we keep them at STP, that is standard temperature pressure, which is nothing but 10⁵ Pascal and 0 degrees Celsius, you'll find that the volume occupied by O2 gas and the volume occupied by N2 gas will be equal. This is what Avogadro's law says. Now I'm sure that after watching this video, next time when you walk into a chemistry lab and see any reaction happening, you'll be knowing that what are those fundamental laws of this nature that is actually working on it. And if you enjoyed my video, please like, share and subscribe my channel, and don't forget to hit that notification icon so that you will get the updates of my latest videos. So we'll be back again with amazing such videos on science and mathematics. Until then, always remember, make learning interesting. Thank you.